The current in any circuit depends on the total resistance of the circuit. So if we're dealing with a parallel circuit, we're going to have to be able to figure out the total resistance of a parallel circuit. So let's take the ideas about the current of the circuit as well as the potential difference of the circuit and put them together with Ohm's law. First off, we just found that the current total coming out of the battery is equal to the sum of the currents across the individual pathways. That would be the loops in the parallel circuit. So this is for parallel circuits, the total current. We also know that V equals IR from Ohm's law. So if we're using I total, we can replace that with V total over R total. And I1 would be V1 over R1. I2 would be V2 over R2, and so on. Another thing that we just found out was that for resistors in parallel, the voltage drop across each individual loop is the same. So if we combine these ideas, V total is equal to V1 is equal to V2 is equal to V3, we can essentially reduce the equation by V and end up with 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 for as many resistors that we have connected in parallel. That's not the same thing as saying that R total equals R1 equals R2 or plus R2 plus R3, but we can say if we inverse both sides of this equation to make it a little easier to enter into the calculator, we can write it like this. To summarize these ideas with some diagrams of circuits, batteries here, again, remember the voltage for every loop is going to be the same, so the rise and the fall through each loop will be equal. So the rise would be through the battery, the fall would be through the bulbs. We're gaining our energy through the battery, we're losing it through each pathway to get back to where we started. The junction rule tells us that whatever current comes out of the battery is split between each path in parallel. So here would be our junction, and the path split means that the current splits. So our total current is equal to the sum of the individual currents. What we just found out was that our resistance total for the parallel circuit can be found using the sum of the inverses, and what that is indicating to us is that we could really replace those 3 bulbs with one total resistance and end up with the same amount of current coming out of the battery if we just had this one resistor in there instead of these 3. That would be the total resistance of this parallel circuit.